In this video we're going to be talking about multiplying monomials, binomials, and polynomials. You're going to have to recall some vocabulary. First being that a monomial is a single term. Binomials are two terms connected by addition or subtraction. Trinomials are three terms connected by addition or subtraction. And polynomials are four or more terms connected by addition or subtraction. When you're watching this video, remember that you can stop the video at any time to finish your notes or just so you can review what was said. In front of you, you should have this paper marked lesson 14.3 and 14.4, and we're going to start off with multiplying monomials and polynomials. The first thing you need to know is the product rule. And the product rule says when you have two things of the same base that you are multiplying together, you are going to add their exponents. Like such. So if I have something to this base that has this exponent and I'm multiplying it times the same base with a different exponent, I simply add their exponents. We're going to use this rule to do this first example. In this first example, you're going to see that I'm multiplying this monomial x times this binomial x plus 4. When you do that, you're going to use the distribution property. So I will take this x and multiply it times x. So that would be x to the first power times x to the first power, and that's going to give me x squared. So inside the parentheses, the first thing I'm going to have is x squared. And then I multiply x times the 4, I'm simply going to get 4x. I have successfully multiplied x and x plus 4. In this next example, I'm going to be multiplying 5m cubed times this trinomial, 3m squared minus m minus 7. When you're doing this and it has exponents and coefficients, you're going to multiply the coefficients together, you're going to multiply the variables together. So let's go ahead and do this. Here I'm going to have 5m cubed times 3m squared. I'm going to distribute into that first variable. So 5 times 5, you'll see, is 5 times 3 is 15. M cubed times m squared, using the product rule, keep the variable and add their exponents. 3 and 2 is 5. Let's multiply 5m cubed times negative m. 5 times negative 1 is negative 5. M cubed times m to the first, when m is by itself, it's to the first power. M cubed times m to the first is m to the fourth power. Five m cubed times negative 7, 5 times negative 7 is negative 35. And then you have that m cubed times nothing over here, so you're going to bring it down to m cubed. Notice it's automatically, in this case, descending exponents, so it's in standard form. Go ahead and stop the video and practice the first 4 items. If you did this correctly, for number 1, you should have k squared minus 9k. If you did this one correctly, you should have 9a squared plus 9a. If you did this one correctly, you should have negative 6p to the fifth plus 48p. And if you did this one correctly, you should have negative 6c to the sixth power minus 15c to the fifth. Let's skip down and do some harder problems. Let's try number 11. It's got two variables. I have an r squared and an s squared. I'm going to take these, and remember, I can't multiply unless I'm multiplying with the same variable, so I can only add the same bases, the exponents of the same bases. So I will wind up multiplying the r's times the r's and the s's times the s's. Let's go ahead and do this. In this case, you're going to multiply this entire term into all three items. So here we have 5 times negative 2 is negative 10. R squared times r squared is r to the fourth. We added their exponents. And s squared, well, there's nothing in this term to multiply s squared with, so I'm just going to bring it down. Now it's this term times the middle term, positive 3rs. So number times number, 5 times 3, that's positive 15. R's times r's, r squared times r to the first is r cubed. And here I have an s to multiply with, so I have s squared times s is s cubed. And then finally multiplying into the last term, 5r squared s squared times negative 4s squared. I don't have any r's to multiply with in this one, so 5 times negative 4 is negative 20. I don't have anything to multiply the r with, so I'm going to write it down. And s squared times s squared is s to the fourth. Notice this is r to the fourth s squared, r squared s to the fourth. These two kind of look similar, but they have different exponents, so that makes them different variables. So I would not be able to add anything together here. Everything here is a different variable. R to the fourth s squared is a variable. R cubed s squared is a variable. R cubed s cubed is a variable, and r squared s to the fourth is a variable. So there's nothing here to combine. Let's do one more. 3ab is multiplied into 4a squared minus 7b cubed. Let's go ahead and do this one. Multiplying the numbers, 3 and 4 is 12. A times a squared will be a to the cubed. B has nothing to multiply with, so I'll put it right there. Then I've got negative 7 times negative 7 times 3 is negative 21. There's nothing to multiply that a with, so I'm going to copy it down. And b times b cubed would be b to the fourth. And there you have it. Go ahead and practice these two. Stop the video. Practice these two, numbers 13 and 14. If you did this one correctly, here you would have negative 63 c to the fifth d to the fourth plus 28 c to the fourth d to the seventh. And if you did this one correctly, you would have negative 20 m to the fifth n to the fourth plus 30 m to the fourth n squared.